Bem-vindos à primeira Open Tech Week da Blip. Welcome to Blip's first Open Tech Week. As part of a multinational, multi-location group like Flutter, a lot of our work is in English, so that's how we will continue this event today. At Blip, we believe that the more we share, the more we learn and grow. This Open Tech Week is an opportunity to give back to the tech community, sharing our challenges and best practices, and creating an open space for learning with each other. Yesterday, we talked about sharing technology that works across our divisions and brands. You can play back the event and continue the conversation here in the comment section, or reach out to us or our speakers directly. Today, we focus on our new betting experience for the Betfair brand and some of the challenges we face while building a new experience. Each of our speakers will be able to answer any questions from you on the comment section of this stream, so please leave your questions and comments, and they'll be commenting back right after their talk. We'll start by hearing from Tiago Pinho, Principal Product Owner in Betfair Channels. As a Principal Product Owner in the Betfair Channels area, Tiago helps shape the Betfair websites and define the features our teams develop for our customers. His talk, How to Build a Million Users Product, will focus on how we are building such a big product from scratch and where we are in our path. Welcome, Tiago.
Thank you. Thank you very much, Mariana. So, are you able to see my screen okay? Yeah?
Not yet.
So, hi everyone. Thank you very much for joining. So, my name is Tiago. I've been working on Betfair for 3.5 years now. And today I'm going to drive you a bit about Betfair and what we do and a massive challenge that we are facing at the moment. So my presentation will focus mainly on the story of a product that we are developing for over 1 million users. And then I will be delighted if you can take some takeaways from this talk. So seeing at these numbers, they may not mean a lot to you, but they definitely mean a lot to us. So they are big. The first number, 2.6 billion, is basically the number of bets that were placed on the exchange just over the last year. 2.2 million is the number of active customers that we have at the moment on Sportsbook. So exchange and Sportsbook are precisely the sports betting platforms that we have on Betfair. Exchange is pretty similar to the stock market exchange. So basically on the exchange, you can bet on something if there is someone willing to bet on exact opposites. So basically, you can bet on Man United to win if there is someone willing to bet on Man United not to win. On the sportsbook, the house will set a price, and then you'll bet against the house. So if you're good to go with the price that you're given, if you win the money, the house loses the money, and the other way around. Betfair is an international brand. It's spread across the globe, across multiple countries, a few dozens of countries, mainly with our international jurisdiction. But then there are some countries that are a bit more heavier in terms of laws. And for those, we need to apply some specifics to our products, so we have some specific implementations. Besides Sportsbook and Exchange, we also have a gaming hub. Hub because we do not develop games in-house, but we have access to a vast catalog of games that we assemble together in a gaming hub. So roughly speaking, it's fair to say that we offer today 3 different products: Sportsbook, Exchange, and games. However, currently, they are a bit isolated from each other. And from a technological standpoint, we can say they are a bit outdated. So turns out they offer limited flexibility and scalability, so which makes the growing costs of new feature development. We are not happy with the amount of content that we offer on site. We believe that we have access to more and we could offer more supporting content. As I mentioned already, it's not pretty straightforward to change between the products and going back. And then every single customer is presented with the exact same experience, like one size fits all. We don't have any personalization capabilities in place, or almost none. And then we feel that we are scoring a bit low in terms of ease of use and on speed from the last service that we run past our customers. So in general, we think that we might be lagging a bit behind our competitors. However, not everything is actually bad news. We have by far the best betting exchange in the world. So in terms of users and in terms of liquidity, we almost have no competitors in this regard. In terms of the sportsbook, it's not only placing bets, but we enhance the betting experience with lots of features. The gaming catalog that we have access to is also really big and really diversified. And then the company is also investing a lot in terms of personalization capabilities and acquiring even more supporting content to enhance the betting experience. So we strongly believe that if we put together all of these pillars, one, the products that we already own, plus the lessons that we have learned and the experience that we have. So recently we have developed from the scratch the Paddy Power products, for instance, plus the investment that the company is doing in terms of personalization, customization, and configuration, we may come up to the market with a game-changing product that's easy, speedy, adaptable, scalable, and personalized. And we truly believe that is going to be the product that will drive Betfair to achieve its strategy to become the world's leading destination for the core bettors. In the meantime, we also have some technical outcomes, being the main one, reusability over bespoke features. This is what is allowing us to deliver faster, because our new product, the product that we are coming up with, is like an empty canvas where placing a new component, new visual component, is like building bricks. So everything can be reusable in the certain context. So, and how do we plan this journey to achieve such a project? So the first step was to get to know our customers and defining clearly the boundaries between the problem and the solution space. On the problem space, user research was the first step, and it allowed us to identify what were our users' betting habits. We felt the need of knowing more about our users. For that, we have done a lot of focus groups interviews. Then we validated the problem. We had to make sure that we know exactly what was the problem to solve. With iterative testing and with lo-fi prototypes, we identified that how to combine these 3 products into a single one was definitely the problem to solve. Then on the solution space, so from the early explorations until the live product, we have been doing a lot of validation processes. So basically, in order to validate the ease of use of core journeys, we used online user testing, which is a fast tool that we can put in the hands of the customer some working wireframes and collect feedback, asking them to perform some actions. We validated design using high-fidelity HTML prototypes just to check how engaged the customers were with our colors and with our value proposition. And then the live product is being validated in multiple ways. since demos, invite to test, break my app initiatives, beta products, and so on. From the user research, we found that we have 3 different customer profiles or personas. The first profile is the fun-driven person. Fun-driven person is a person that basically bets to make the matches more fun to watch. He doesn't really care about what he's betting on, so basically he bets in what he knows. He basically just is looking for more excitement while watching the matches. The knowledge-driven guy is the guy that does a lot of research before placing a bet. So he sees the betting as an opportunity to challenge his knowledge and to challenge his peers and to challenge the bookmaker odds to prove that's knowledge about that subject. So you can figure out, you can imagine how many research this person does, and how many supporting content we need to offer to these profiles in order to make them and their betting experience pleasant. So the last profile that you have is the profit-driven one. Profit-driven bets in something where he sees an opportunity to make money. So he often uses the APIs that we have in Exchange to open and close position just to secure some small amounts of profit, but in a very repetitive way. So these 3 customers, or this kind of customers, besides telling us what their betting habits are, conveyed on agreeing that we have 6 areas that we need to be absolutely world-class in order to deliver an easy and speedy product. The first area is the joining and logging. This is related with all of the registration process, how easy it is, how speedy it is, and about the login capabilities. So what are the login methods that we offer? Touch ID, face recognition, you name it. Then the depositing money process, it's all about charging your accounts. So how reliable and trustful this process is, how many payments methods we offer. Navigation, which is the monster. Basically, navigation is everything that comprehends performing an action on site, how easy it is to find a market, an event, a team, a promotion. We have the bet placement and promos. So basically, this is our checkout process. So it's how fast and secure and reliable it is to place a bet. We have bet tracking, so you can track how you are performing. So are your bets winning bets? Are you winning money, losing money? What are your options? Edit, cancel, cash out, and so on. And then the settlement and customer service, which is basically the support that we offer to tell the customer why this is not a winning bet, why their money is not yet on their accounts. Having in mind these 6 areas, we went out, start raising features, and we raised a lot. So far, I can tell you that we have raised approximately 750 features. So among so many features, you ask, how can we prioritize them? So the Canny model was the model that we use to prioritize features because it differentiates the features by being fundamental. Fundamental are the ones that won't delight of your customers because they take them for granted, but if you don't have it, you'll be out of the market. It's like your power supply, your water supply in your apartments. You have to have them, otherwise no one will move to a new apartment without those services. Then you have the expected features. These ones are the ones that will wow your customers. They will be delighted if they see them there. They will be unhappy if they are not there. The attractive ones can cause a positive impact once delivered, but they don't make any difference if they are not. Indifferent ones are the ones that doesn't make any change, they don't make any difference in the satisfaction level, and then you have the reverse, which are the ones that you should avoid doing at all costs. But as you can imagine, among 750 features, there are lots of expected and lots of fundamentals and lots of attractives. So how can we tie-break them? For that, we use the weighted shortest job first module, which basically comes up with a score that takes in consideration business value, time criticality, risk reduction, and estimated size. So basically, everything that's high value and takes low effort is what we should be doing now. Everything that delivers high value but requires more effort, it's coming up next. And then we'll leave the remaining things for later stage. And if they deliver almost no value and requires a lot of effort, we must consider not doing them at all. So having now our features prioritized somehow, we felt the need to put in place a requires management governance process so we could drive the project through. For that, we come up with a forum, a single and repeatable forum that's open to all functions. Basically, design, product management, product owners, technology are all invited to participate on this. And we divided this forum in 3 different phases. On the identify and validate, basically product owners and product managers step up and communicate to the full set of stakeholders what's the problem that we are trying to solve with a specific requirement, how does this align with outcomes, how it will look like to customers. Basically, we present and discuss requirements and provide visibility over potential risks. Then, as you can imagine, you have requirements that take very long to be delivered. They can span across multiple sprints. So we feel the need, in order to deliver value earlier, to break them down into iterations. And then on the planning area, we basically communicate that breakdown. So we define the goals for each one of the iterations so the full audience can know what to expect and when. At last, we have the build and land. Basically, this happens every time we release something new, and then we run a demo so we can validate against the requirements and against the design what has been delivered. So if we spot some gaps, we can rebaseline against further iterations, and this is our, roughly speaking, this is our sign-off process. So with so many people and so many teams, we have so far 92 teams allocated to this project, not all allocated with a 100% allocation, but 92 teams are contributing for this project. We felt the need of grouping the teams in areas of expertise. So we have working groups, and each working group takes care about its own area, and we scale agile this way. So my teams are working on the sports product experience, for instance. We just take care about all of the user journey to place bets on the sports products. But then we have also other areas just focusing on keeping our customers engaged, others focusing on acquiring new customers, others on driving relevancy for our products, others monitoring performance of our products, you name it. And then in every of these areas, we have people from all backgrounds. So technology, product management, project management, and so on. So we have multidisciplinary teams working in these working groups. So since the early days, when we start having something actually that's workable software, we felt a need to come up with some milestones to validate with the core experience. So even if it's not the product itself, working functionalities like single bet placement and navigation were, since the early days, tests against the customers. So we defined an audience, we defined a format, qualitative, quantitative, we defined the methods, face-to-face interviews, observation, service, and we validate this against the customers. So once the products kept evolving until a phase that it was a bit more complete and robust, we reached a phase of closed beta. So we sent out invites to some specific customers to start using the current product and the old one simultaneously to provide feedback. We evolved a bit more and we reached open beta, so everybody that was willing to test was welcome to do it. And then we are on the phase of migrating customers, which means that there are some customers that are already being redirected to the new product, and they can no longer use the old one. So we are migrating them into chunks, so the lower value ones first and in lower amounts, so we can collect feedback to build up confidence to complete the migration process. So, and all of this feedback that we receive along the way has as well a process in place so we can parse this feedback. This feedback is collected in multiple ways. User testing, as I mentioned several times, behavioral analysis or GTM, customer surveys that are sent after invitation to opt in. We have a feedback mailbox that's accessible from users and from internal users as well. We have active performance monitoring tools in place, and we do lots of diary study focus groups. And then all of this feedback convey to a process where we analyze on whether this is a quick win or it requires a bit more exploration. If it is a quick win, typically we change some configurations and we release this immediately to production, and we reloop again to see if we met the problem. But if it's not the case, if this requires more investigation, this falls a prioritization against the other features that we have planned on the roadmap. So we prioritize the areas to be improved, then it might go to design as well, more user testing, design recommendations, we ask for that for estimations, and then this enters again the delivery process of delivering and land to the customers before we sync again to the start of the loop so we can collect more feedback. So the main takeaways that I would like to share with you is that since the very beginning, it's working pretty well because we are making decisions over data, based on data over gut feelings. So it's basically the customer feedback that's driving our priorities. It's the customer satisfaction that will tell us when we are going to migrate the remaining customers. So we need to make sure that the migrated ones are happy and engage with the products before we start migrating the most valuable ones. And we use customer data to identify the areas to improve. So an approach on that iterative delivery approach, as you could see a few slides ago, we always felt that we should fail sooner rather than later. So we need to validate our hypothesis, and if we have to fail, it's better now than wasting a lot of time developing things that the customers won't value. And then in such a big project, lasting for so long, it's absolutely impossible to be resilient to change. So basically, we need to embrace it and learn along the way. So hope you enjoyed the session. I'm more than happy to take any questions that you might have on LinkedIn comments, or if you need, just email me directly. Thank you a lot for watching.
Thank you, Tiago. Remember, Tiago will now be answering your questions in the comment section of this stream. And we'll now hear from Luís Pinho. He's a principal QA engineer in Betfair Channels. And as a principal QA engineer, Luís is deeply involved in our testing framework and the evolution of our continuous delivery processes. His talk, Behind the Scenes on Quality of Betfair Rebuild, will give an overview of something that is often a second thought when building something from scratch. How important it is to think and embed quality from the beginning of a project, covering all of the stages from the moment the code leaves our laptop until it is deployed into production. Welcome, Luís.
Hi, Mariana. Thank you very much for the brief presentation. Hello, everybody. My name is Luís, and I will talk about something that is often overlooked when companies start a project from scratch, which is the quality testing side of it. In this presentation, I'll briefly talk about the problem's context that we had in hands and how important it was to start building around quality right from the start until the present day, where we have more than 100 people contributing to the same code base. So at the start of this project, a team of 7 people was formed in order to create a new web and mobile application that would group Betfair's 3 biggest products, Exchange, Sportsbook, and Gaming, into just one, the Betfair Rebuild. There were some things that we knew for sure from the start, others that we didn't. So regarding the ones that we knew for sure, we knew that we wanted to have a web mobile application, both iOS and Android. We also knew that we wanted to use our CI/CD internal technology stack because we already had the infrastructure in place, and that helped us achieve our needs really fast. We also knew that we would need to group all services consumed into a backend aggregation layer. This would serve as an interface for the front end. We also knew that we wanted to have a design system for all the front end components. And finally, we also knew that we wanted to have all our defined test cases centralized in order for all the QAs from different teams to be able to access them faster and easily. The main thing that we didn't know was the application architecture, which on a personal level, it's really the best tool that we as a QAs have to design our test architecture. I say this because there's no such thing as universal and rightful strategy for every project or system, right? There's only the best strategy for each situation. And in this case, we couldn't yet start designing our test architecture without really knowing our applications architecture. The tools needed to solve this problem, it's something that comes always after, like the front-end, back-end testing framework that we would be using. It's something that will help us achieve the architecture that we wanted to have. So on a very, very, very high level analysis, we started to design our application architecture, and we knew that we wanted to have a front-end layer that would support web and mobile, and a design system that would serve the front end with its components, as I referred before. The backend layer would be an aggregation layer with tons of logic from all kinds of services that we wanted to consume that will eventually serve the front end with pre-established contracts. All these services, like these dozens of services, are not our responsibility. We don't control these services, but we are responsible for aggregating all of its data into the front-end service. So taking into account the previous design of our systems architecture, we could finally start planning how we will test each layer individually and its consequent integration. What we know for sure is that we don't want to use a testing framework that is coupled with a front-end framework. For example, I can give you the example of Protractor and Angular. Despite nowadays they're not so tightly coupled anymore, but I think you get the point. We also wanted something that was really fast when it comes to test execution, both locally and within our CI/CD ecosystem. The tests should also be decoupled, and this means that each layer should be tested individually, so each component can be reused and have its quality always certified. And we also use the test pyramid as our starting point. So the test pyramid, for those of you that don't know, it represents the various types of tests and the frequency at which they should appear in the code-based test suite. What we did differently here is that we decided to use one pyramid for each layer and not one pyramid for the whole project. This comes in hand with the decoupling I talked before, because it will allow us to have a better quality across projects, both individually and regarding the integration of the different services. Of course, you can't have all kind of tests for each layer. For example, you can't have end-to-end tests on the backend layer, but I will go into that later. So finally, we can start to define what technologies can help us achieving those needs. And these are a brief summary of the ones that we use. So regarding tests, we chose Jest for the unit tests and WebDriver IO for integration and end-to-end tests. The main reason for this decision was the fact that it is open source, has integration with Selenium Grid, something that we built internally in order to have more autonomy and to better parallelize our tests. Also, another huge pro for this framework is its out-of-the-box Appium integration that we will be using for our mobile tests. So having this architecture defined and technologies that will help us achieve our goals, let's take a closer look between the layers and how do we approach the testing of each layer. So let's start with the backend layer. In the backend, we started to define a threshold of 84% of coverage for the unit tests. This is not applied only to the backend layer. This is applied to all the code base. And as we know, the coverage is a nice indicator, but it cannot be the only one, because coverage alone doesn't guarantee us that some edge cases will be tested, right? And this can also lead to the false security for people to developing tests and be more concerned in achieving this threshold than really testing real relevant scenarios for that specific code. So yeah, 84 was a nice balance that we found for the unit tests. And we also need to test the integration between our backend layer and the services that it consumes, as well as the consequent integration with the front end, right? So in order to achieve this, and since we have no control whatsoever of the data that the services gives us, we are using WebDriver IO along with mock server in order to test this integration. So in order to test this integration and our aggregation layer has the correct behavior, we need to simulate scenarios where, for a given front-end request, a set of data will be returned in accordance with what was asked. Okay, so in order to achieve this, we mounted a mock server, which is nothing more than a dummy service that records response requests. We then launch an instance of our backend where all its endpoints will point to the address and port of that mock server. And the test itself always starts by defining all the interactions that will happen for that given scenario. I can give you a practical example of this. For example, let's say that we want to test a front-end call that wants to know the current state of a football. In order to achieve this, the backend needs to access service 1 that gives us the time elapsed and service 2 that gives us the current score of that game. To achieve this, we record an expectation for service 1 that responds, for example, 30 minutes, and one for the service 2 that will give us the result of 1-1. Now, as soon as we start to test and simulate the front-end call to these endpoints, our backend will call the mock server on that endpoint, and the mock server will have that previously expectation stored, and it's ready to respond within milliseconds with the correct data that we stored. Now we just need to validate that the set of data that our backend will aggregate and respond to the front end is correct. All of this happens inside a container, which facilitates us the network abstraction. So that's it. That's really simple. It's just creating a dummy service that records all interactions between services, and then the backend goes there, gets the information that it wants, and then we validate afterwards the coupling of this information for the front end. Now that the use of mock server to mock all endpoints will help us validate the internal behavior of our aggregation layer, but it will not validate that we'll be compliant with the new set of data provided by an external service, right? Because if we mock all the endpoints and its interactions, we are assuming that all endpoints will be static. But when API changes happen, we can have problems by not testing them. Of course, unless we consumed a very limited number of services and we knew every time that they changed. But in such a large-scale project as this one, this is something impossible to handle manually. So in order to automate this and to really validate this API validation, we implemented a set of contract tests, because this kind of tests go beyond schema tests, and they require that both endpoints have an agreement of their interaction. We decided to use Patch.js to generate and validate these contracts between our aggregation layer and our services. So an example of this is, for example, within our aggregation layer, we'll make a call to a given service. The given service will actually have a real response to us, but we will only validate the contract between our call and what we got. Like, for example, I got a string on this JSON, we got the Boolean on this field, and not the real information of it. For that, we have the mock tests. So yeah, this is basically our backend layer tested. We can now move into our front-end layer. We will start by the design system. The design system will be responsible to store all the front-end components that will be later integrated into our web application. This will live in isolation on the design system. So while all of this can be tested on the front-end side, it would be a lot heavier and time-consuming because we would need to mock and render an entire web page just to test a given edge case of a given component, right? And since we have a design system that has its own deploy within our internal infrastructure, it made more sense to us that these components would be tested in isolation every time a new version of code is deployed on this design system. This allows us to find possible bugs way earlier within our developing process, even before its integration with the front-end client. As all of the components are dummy, we decided to only test them visually. using component screenshots. And this doesn't also validate that their integration with the client will be tested afterwards. But as soon as these visual tests pass on each deploy, we have the confidence that those exported components are in accordance with the specs. So for this reason, and since we have the unit tests for the component, we have the component itself, we have the visual tests for this component, we also created the page objects, which will be the code representation of that component on our page, and we export them to the client. So with this, each component can live in an isolated and decoupled way, and we can have a more truthful lifecycle since its creation until its deletion in our code base. When we finally get to the web and client mobile, as we saw before, we have already some confidence when it comes to visual component and backend responses that are used to feed our pages. However, we still need to test their integration and have some end-to-end tests that we don't mock any services and validate some data on the page. Because as we know, if we mock everything on a page, but the service is returning as a 404, for example, we will have a green status. The test will pass, right? Because all the endpoints are mocked. So despite all of the unit tests, we want to essentially have integration tests on our pages. For a given previously mocked backend call, how will the application render the respective components on the page? This is what the integration tests will test. And on top of all of these tests, we also have visual tests for the entire page, like a full page screenshot with mock data, of course. And this integration reflects the final state of a given page. Since all our data is mocked, these tests run inside a container. It's pretty easy, and we don't have problems like with different resolutions, different operative systems, and whatnot. Also, there's no much difference between mobile and web tests, and this is one of the main reasons for choosing the technologies that we choose. This allows anyone that is developing for web or native to switch context very easily because all the test stack is almost the same. Like the only real changes happen infrastructure-wise, obviously. But if you are developing tests for your feature on a regular sprint, most likely you won't have to worry about any of this. So, and that concludes for the front-end layer. How do we incorporate this on our CI/CD? Let me just say that another feature of our project is that we decided to have all our code within the monorepo. So this means that the front-end, back-end design system tests, all our mini packages that we use within our application live on the same code base, on the same repository. And this, as you can imagine, brings us some complexity to our ecosystem, but let's try to keep it a little bit simple for this presentation. So let's do a quick exercise here to showcase how our CI/CD behaves. Let's assume that I'm ready to merge a new component on the design system that will be incorporated in our client and also have backend code to these new components. So almost all of our code base was like touched for me with these merge requests. So what happens next? So the quality checks start as soon as we open a merge request. When this happens, or we update this merge request, there's one Jenkins job that will be responsible to validate syntax and types, and will also run unit tests that will verify the coverage. Another thing that the person that opened the merge request can do prevently is to run the regression and the visual tests for that specific branch, that specific code version. In order to achieve this, we just spin up a container with our app running. We also spin up a Selenium grid and run all the tests on that Selenium grid pointing to our instance of our app running with our code that is presented on this merge request. This enables us to avoid red builds that impact other developers and find possible bugs earlier. And since this does not impact others' work, because all of this happens when the merge request is open and not when the code is merged into master and the actual pipeline starts. We can run this how many times we want in case that we are changing our code regularly on the merge request because of comments, and in case we decided that our code was not good enough and we decide to make it better, for example. So as soon as we merge our code into master, and taking into account that this merge request has changes in every layer of our architecture, there are some Jenkins jobs that will be triggered, as you can see here. So in this phase, and since we have passed through those validations on the merge request phase, every component will essentially build an RPM. And these RPM will be used to be deployed in our environments. The only difference in these 4 builds is that we only create an RPM for our backend layer in case its contract and regression tests pass. This happens because since there's no dedicated environment to deploy our backend layer, it's only requirable for the front end. We needed to ensure that the RPM will only be generated and ready to be requirable if all the tests pass successfully. In this graphic, we can see what happens as soon as the deploy of each component finishes. This is basically a graphic representation of what was described before when I showed the pyramid for each component. So in short, each component is deployed in its respective environment, and all the regression visual end-to-end tests will run against this deploy. So when all the pipelines have a green status, we have the confidence that this code version is ready to go to the next phase. And what is the next phase? It's what happens between our QA and production environment. The fact that we have a green build in QA almost guarantees us that everything is ready to be shipped, but the endpoints used, because in QA we have different configurations, endpoints, firewall rules, etc. So in order to have even more trust in our build, we go through a pre-production environment that is essentially a mirror of production. And in this environment, we run a really small, for now at least, test suite of end-to-end tests, just to validate that the endpoints are correct, and also to save some manual tasks that are repetitive, that as QAs always do before a release. And as soon as these tests pass and all the QAs give the good to go for this build to production, then we finally are ready to ship this code into production. Also, we ship using a blue-green deployment process, which allows us to find possible errors in machines or even on the application before it's available to our customers. So taking into account everything that we've talked so far, and given the complexity of all of our CI/CD phases, the number of tests and suites that we have, it would be assumed that this would take ages to run, right? Well, while this could be true, it wasn't until now, at least. Let's go into more details. And given that all of this still has a ton of room for improvement, I actually screenshot the Jenkins jobs and posted here. So these are the approximate main duration times for each step of our pipeline. So I want to start just by highlighting the approximate 39 minutes of static validations on the first phase. Just a reminder that those 30 minutes of tests are optional, but they are greatly help everybody in finding possible errors beforehand, so they are really useful. And they do not impact the pipeline directly, so it's a win-win situation for all of us, really. After merging, we have reasonable times for each component, everything taking between 6 and 12 minutes, depending on the component. The 12 minutes, for example, is for the backend layer build, and don't forget that those 12 minutes already contemplate the tests, the contract and regression tests, so it's expected that it takes a little bit more than the other ones. So finally, when it comes to tests, visual and regression tests, don't forget that those number of spec files only correlates with the number of actual test files, and because each test file can have different scenarios and different tests, more than one test in it. But in sum, we have like 295 test files running under 3 minutes for web, all in parallel, of course, and around 32 minutes for iOS tests. And this happens because we are only able to parallelize with 3 simulators for now. It's something to improve in the near future, I guess. So yeah, we are finally in production, and I hope that, I know that there's tons of rooms for improvement, and that's something we try to do every day here in Blip. I really hope that this presentation sheds some light on how important it is to not ignore quality from the start and always have a quality-driven mindset when working on different projects. Again, what worked for us might not work for your project, but on a personal level, I learned from everybody's approach on different projects. So I really hope that this presentation will help some of you guys out there. Again, thank you all.
Thank you, Luís. Luís will now be answering your questions in the comment section of this stream. We'll allow for a couple of minutes for both Tiago and Luís to interact with you in the comment section, and then we'll close the session. Thank you for joining us in this second day of Blip's first Open Tech Week. Feel free to browse our website for more information on Blip and the Flutter group, and reach out to our speakers or to us directly here on LinkedIn if you feel the comment section doesn't cover it. I'll see you tomorrow at 6 p.m. here on LinkedIn for a couple of talks on automation and some of the unique challenges we have to operate our platforms globally. Obrigada e até amanhã.